All yours.
All right, guys. So how's everybody doing today? So today we're going to cover the nursing workshop. This is going to be for the class RNSG 1208. This is going to be for first semester entry students. This class is going to cover everything regarding math. I'm going to cover a little bit on conversion factors that you will use, some units that you will frequently be using, not only in the first semester, but all through the course of the nursing program, which is, I believe it's 4 semesters. Now, uh, this course is really intense because it consists of many math problems that students are not familiarized with. Many of them are, but the majority of them are not. And it's really fast paced. So it's really good to understand the techniques and what to look for in the problems in order to save time because the exams for this course they are really time consuming and like I said it's really fast paced and really intense. So with that, I'm going to start the slideshow. So what we're going to cover, or what I'm going to cover, this is the outline. I'm going to start with what is drug dosage about, okay? And then I'm going to use some examples regarding rounding, going back and covering some rounding and the rules of rounding. Also time regarding what you're going to actually see in the problems and what you're going to see throughout your practice as a nurse. Some equivalents and conversions. This is going to be the key to actually solving the math problems that you guys are going to be seeing throughout the course. Commonly used units, solutions, some important abbreviations, medical terminology, and finally dimensional analysis. I will not cover examples and try to resolve problems just due to the timing. So let's start with what is drug dosage. Okay, so first, breaking it down, the dose is a specific quantity of medication taken at one single time. Okay, for example, you're going to take a dose of ibuprofen at 200 milligrams. That's the dose. Okay, the dosage describes a specific amount and schedule of the administration. So this means, okay, how many doses are you going to have throughout a day, throughout a period of a week or a month, whatever treatment is going to last. And of course, we have to cover what's a drug. Well, that's a substance which has a physiological effect when ingested, administered, or consumed. And you can have many types of drugs. For example, your over-the-counter drugs, Tylenol, uh, ibuprofen, and then you have your recreational drugs, and of course, more over-the-counter, just as cough syrup. So starting with rounding. Okay, so what is rounding? So rounding is a method of altering a number or a specific amount to one less but more convenient, less exact but more convenient for calculations. Okay, and rounding, it's really straightforward. I don't want to call it simple, but just straightforward. Every time you have a number, okay, and you want to round it up, you're going to use the rule that if the number or the number next to the number you want to round is less than 4, that number will not move. Specifically, it will not go up. Okay. If the number is more than 5, then you have to round to the next value. For example, if you have a 1.2 and you want to round up that 1, you have 1.2, then you will leave it at 1. Okay. But if you would have like 1.5 or 1.6, if you want to round that number up, you will round all the way to 2. Okay. And this chart is going to demonstrate how the actual numerical uh, units are going to be setting up with when you have to round. Okay, this is really important, specifically when you're dealing with the decimal points. Okay, so I want to focus on the region on the right, which is going to be the decimal part. So anytime you have, I focus on this one, the numbers right up to the decimal point, you have the tenths, the hundreds, and the thousands. These are going to be the positions, okay, and you're going to be hearing this very often. So get familiarized with this. So the tenths position is going to be the number right next to the decimal point, okay, following with the hundreds, following with the thousands. You won't see more than that, okay, as well, at least for this course. So now, like I said, it sounds really simple, okay, specifically with numbers, okay. Like the previous example was given, when you have a whole number, let's say you want to round 1.56, and you want the whole number, then you will round all the way to 2. You will have like 2.34, and you want that whole number, then you will round to 2. Now, this one decimal place thing. you're going to listen a lot in the problems and read the problems that, okay, round it to one decimal place, round it to two decimal place, things like that. So for example, on this one, you have to round this number 1.76 to one decimal place, you would have 1.8. Okay, same for 1.44, if you round to one decimal place, you would have 1.4. Now, that's just regarding numbers. During your nursing practice, you're going to round other things that are non-numbers. And the most common things are going to be drops and tablets. So when you're dealing with a problem like this and you want to round with a drop, there's no way you're able to cut a droplet, right? Unless you have a micropipette, like in a research laboratory. But in real life, you're not going to be able to do that. So when you have drops, you're always going to round to the nearest drop. You're not going to have half a drop, quarter of a drop. You cannot. So always drops, round to the nearest drop. Regarding the tablets are going to be round to whole, half, or one quarter. Why? Well, because many tablets are going to be scored, including the ones you buy over the counter. You can just cut that tablet and take half of it. That's your dosage. So for example, on here, some rounding examples. On one, we have rounding to a whole number, 3.980. You want to round it to a whole number, I'll give you 4. 5.09, you want to round it to a whole number, I'll give you 5. Okay, same for 8.75. Notice how the rule of numbers greater than 5 is going to affect here. 8.75 will round up to 9. Okay, now an example going to the tens place, you have 3.1415. If you want to round that to a tens, that'll give you 3.1. Okay, now for hundreds, 12.34. And the thousand, same things, 1.6666. You'll round that to 1.667. Now, on the chart on the right, it's a little bit different. Why? Well, because you have now the drops. If you have the drops, 22.2 drops, if that's going to be the indicated order or the indicated dosage that you have to give to that patient, you will leave it at 22 drops. Okay, like I say, you cannot cut a drop in half. Okay, but for example, on the tablet, you want to round the tablet, 0.8 tablets, round it to the nearest half or whole tablet. In this case, because you have a number greater than 5, you will round up to 1 tablet. Okay, on example 9, you have 23.7 drops. You will round that up to 24 drops. Okay, and on the last one, 0.48 tablets. Well, that will give you the closest one to half a tablet. That will be the closest number that you could round out a tablet to. So now, time. Time is a really, really fun subject for me. Okay, I not only in drug dosage, but in general in my life, I really enjoy time. But you have to be familiarized with the notion of time. Okay, everybody knows that in one day there's 24 hours. In 1 hour there should be 60 minutes, and in 1 minute there should be 60 seconds. The majority of us know this, but when we are under pressure, especially nursing students, when you guys are under pressure, you tend to forget these things. So practice a lot the notion of time. Okay, why? Because you will be assessed on how to administer drugs based on time, okay, and based on doses. So here I have a quick example. Let's say the patient has to receive 3 doses in a day. That means that there's going to be 1 dose every 8 hours. Okay. Another example is that, let's say the doctor says there's going to be 1 dose every 6 hours. Well, you need to know that that means there's going to be 4 doses in a day. Here, we're just dividing the time into hours. So really, really important topic, and really important to remember the notion of time. Okay, now covering again time. Nursing students and the majority of us are not familiarized with military time, unless you were in the military, of course. But during your nursing practices, this is going to be the time that you're going to be dealing with. And this chart is really, really useful because it shows you the military time conversion. Okay, so the military time covers from the 000 hours, okay, all the way to the 2400 hours. That's a full day. Okay, it's pretty simple, but you need to get used to it. You need to practice on this. So as you can see, going clockwise, 1 a.m. will be 100 hours. 2 a.m. would be 0 to 100 hours, and so on until you reach midnight, which then will be a new day. Okay, you will reach 2400 hours or 0 hours, giving you through a new day. Okay, so now going with equivalence. This is probably the most important thing that you have to know in order to solve the mathematical problems that you will be seeing. The mathematical problems, honestly, they're not really complex if you know what to look for. So I'm going to cover equivalence. So an equivalent is an equal or interchangeable value or quantity. Here, I give you some examples. For example, here in El Paso, we love tacos. Everybody loves tacos. So I give you 1 kilo of maseca, okay? That will give you the equivalent of 30 tortillas. In other words, you need 1 kilo of maseca to produce 30 tortillas, okay? Going into medical terms, talking about drugs, one tablet will give you 10 milligrams in this example. Of course, you can have many other concentrations in the tablet, but this is an equivalent, okay? A specific thing that matches a specific quantity. 1 kilo of maseca will give you 30 tortillas, okay? And 10 milligrams will equal to one tablet, okay? So now this chart is going to be really, really useful. It's not only going to give you equivalence, but also going to give you conversions. Here in the States, we tend to use a lot of inches, feet, yards. But in this course and in the rest of the world, the metric system is covered. So many of us are not familiar with that metric system. So this chart and another one that is going to pop up later on is going to allow you to have those conversions in hand, okay? This is really important to be memorized, learn it and memorize. I'm not really sure if you can use the chart during the exam, but I'm assuming you cannot. So this is going to allow you to know, okay, what are the equivalent values? So let's start on the top. So you have 2.2 pounds. Okay, so when you go to a doctor, they tell you, okay, you're weighing 200 pounds. Okay, so we need to know that 2.2 pounds is going to equal to 1 kilo. Okay, that's basic conversion. Now, if you want to go to ounces, to solid ounces, 1 pound will give you 16 ounces. Okay, and then we go into conversions in the actual metric system. Okay, so the metric system is really nice because it's usually going to move among units in 3 decimal places. So for example, you have 1 kilo, and if you want to know how many grams are in 1 kilo, well, 1 kilo equals to 1,000 grams. Okay, and then you move to smaller units. You can find out how many 1 gram will give you how many milligrams, or 1 gram will give you 1,000 milligrams. You can even go to a smaller unit. 1 milligram will equal 1,000 micrograms. Now you have microdrips. So in a microdrip, it's going to be the setting of the pump, okay, how the drug is going to be delivered. Now this is really important. The microdrop or microdrip set is going to show off a lot in your actual problems, but you can have others, okay? Your instructor should be specific on that. So on this one, microdrip set will always going to be 60 drops or 60 GTT per ml. Okay, so that one is crucial to be memorized. Now moving forward, 1 cup will give you 240 ml. Okay, and 1 cup converted into fluid ounces. Okay, not solid, fluid ounces will give you 8 fluid ounces. Okay, now on the chart on the right, 1 milliliter will give you 1 cc. Many of us have, I don't know, protein powders at home or types of drugs, whatever, that are powder, and the cup which you use to scoop it out sometimes is measured in cc's. Okay, it's simple. 1 cc will give you 1 ml. It's also really important to be memorized. Now going back to fluid ounces, 1 fluid ounce will give you 30 ml. 1 teaspoon in our houses, we use teaspoons. It's really strange that we have actual syringes. So the way to measure a drug usually going to be with tablespoons or teaspoons. In this case, 1 teaspoon will give you 5 ml, and 1 tablespoon will give you 15 ml. Okay. Usually, 1 ml, if you want to have a quick conversion, and they're not telling you a microdrip set, and they're not being specifically telling you that, okay, there's a specific amount of drops in per ml. Usually 1 ml will give you from 15 to 20 GTTs. Okay, that's a common conversion. And now you have the liter. 1 liter equals to 1,000 milliliters. And you can convert in between teaspoons and tablespoons. 3 teaspoons will give you to 1 tablespoon. And 2 tablespoons will give you 1 fluid ounce. So now these are common units that you guys are going to see. Okay, you won't see any other. You will probably won't see all of these units, but these are the most common. So feel free to take a picture of this one, make a copy of it. It's going to be really useful. Okay, so I'm going to start with the mass in orange. Okay, so you have the units. Okay, so if you want to, the unit for kilo will be kg. Okay, as you know, I covered earlier, 1 kilo will give you 1,000 grams. Okay, grams will be gr. 1,000 grams will give you 1 kilo. Milligrams will be mg. Okay, 1,000 milligrams will give you 1 gram. And micrograms, you could see it as mcg or ug. It all depends on who's writing the problem. But 1,000 micrograms will give you 1 milligram. And then pounds, okay, pounds will stand as lbs. Okay, so 2.2 pounds will give you 1 kilo. Okay, and then ounces will give you oz. 1 ounce will give you 28 grams. And then I'll move on to the purple ones, which is length. So you have kilometers. Kilometers will be the unit in km. 1 kilometer will give you 1,000 meters. Okay, meters, the unit for meters will be mt. 1 meter equals to 1,000 meters will give you 1 kilometer. And then you have the centimeters. These are starting to be more familiarized. Centimeters will be the unit cm. Okay, 100 centimeters will give you 1 meter. Then you have millimeters, which should be mm. 1,000 millimeters will give you 1 meter, and you move on. Now, the two on the bottom, feet or foot, those are really important to know. Okay, 1 feet will give you 12 inches. This is really important because you will bump into some problems where you're going to find the height, and you have to calculate whatever height they use in order to calculate a specific unit, in this case, a BSA. So it's really important to know the feet and the inches. So 1 feet will give you 12 inches. Okay, and if you want to know the conversion of inches to centimeters, 1 inch will give you 2.54 centimeters. I forgot to put the unit on that one, but 1 inch will give you 2.54 centimeters. Now regarding volume, okay, you will not be dealing with gallons and things like that. You'll be dealing more with liters, milliliters, and ounces. Okay, so a liter will give you 1,000 milliliters. Okay, and vice versa. And then the ounces, 1 fluid ounce will give you 30 mLs. And like I said earlier, usually 1 milliliter will give you 20 drops. So these are going to be the units that you guys are going to be seeing throughout not only the first semester, but the entire nursing program. Okay, so some quick conversion exercises, like I said earlier, just practice the conversions, know the equivalents. So the example I gave you, a tortilla, 1 kilo of maseca will give you around 30 tortillas. Okay, 3,100 grams will give you 3.1 kilos. 90 mLs will give you 3 fluid ounces. 4.8 meters will give you, 8 meters will give you 800 centimeters. And then you have 1,500 micrograms will be 1.4 milligrams. 5 kilos will give you 11 pounds. 2 tablespoons will give you 30 mLs. 3 teaspoons will give you 15 mLs. And 84 grams of mass will give you 3 ounces. Solid mass, not in volume. Okay, so it's a little bit different, but you guys can use it interchangeably. Now on solutions. Solutions will probably be one of the most complex, or what the students find very complicated, but it's actually really simple once you get the hang of it. So the definition of a solution will be a homogeneous mixture where one substance, called a solute, okay, usually the solid substance, will be completely dissolved in a solution, called as the solvent, usually it's going to be the liquid, and it's going to be forming a uniform mixture. Okay, now the problems that the students will be encountering regarding the percentage, okay, is usually going to be the amount of solute of substance over a specific amount of volume. So there's going to be a rule, okay, always X amount of percentage, it doesn't matter if it's 1%, 100%, whatever, but X amount of percent will always going to be the X amount of solute or solid in grams over 100 milliliters. So for example, if you have a 10% solution of normal saline, that means that you will have 10 grams over 100 mLs. And this could be manipulated as you want. For example, you can. I'm gonna go ahead and start writing. In this case, you will have a 10% solution. That will be the 10 grams over the 100 mLs. But let's say you want to make it simpler. Okay, let's say you only want to make 10 milliliters of also the same percent solution. Well, so that will give you 1 gram over 10 mLs, and that will be still 10% solution. So this is the idea. Okay, the numbers could be interchanged. You can bump into problems where you have to find out how many grams you have to find, or you have to use to make, I don't know, a 5% solution, but you have to make a 500 ml solution. So as long as you remember, okay, that's always X amount of solution will equal X amount of grams, or in 100 milliliters, you will be fine. It doesn't get more complicated than that, but you have to learn this rule. So I'm going to do some examples. So let's say you want to find a 5% solution of normal saline, and you want to make 400 mLs, and you want to find out how many grams you need for that. So when you want to find out anything in this course, you always are going to start with that. So in this case, I want to find out how many grams I need for a 10% solution of 400 mLs. You're looking for with the top number that you're going to plug in. Okay, so you want a 10% solution, you know that's going to be 10 grams over 100 mLs all the time. But in this case, you want to find out how many grams you need for 400 ml solution. So now that you set up the equation, you multiply across on top and divide by the bottom. So in this case, it will be 400 times 10. That will give you 4,000. And then you will divide by the bottom, which will be 100 mLs. So after doing the division, you will need 40 grams for a 10% solution. That will be 400 mLs final volume. Pretty simple. You just need to memorize all the time that X amount of grams, X amount of percentage equals to X amount of grams over 100 mLs. As long as you remember that, you're going to get. So now going through some common abbreviations. So the abbreviation GTT will give you drops. Okay, you'll bump into also MEQ, which is really, really common. That will mean milli equivalent. Okay, and then units that will only give you unit. You can also bump into milliunits, but it's going to be just milliunits plus milliunits. BID, really, really important. That's twice a day. TID, 3 times a day. QID, 4 times a day. Other important medical abbreviations, PRN, that is as needed. Okay, and then you have PO, that will give you by mouth. QH means every hour. Sub-Q means subcutaneous. IM means intramuscular, and IV means intravenous. Okay, so this chart will help you a lot to understand those medical abbreviations. And to be honest, you won't see more complex than this. So keywords to look for, okay, when you bump into an actual problem and you're actually going to be digesting it. So every time you see administer, that means the dose that is going to give in to the patient, only the dose. Now, that's very different from the treatment. The treatment is going to be the total time that the patient will be receiving the drug. It could be weekly, it could be daily, or maybe just once. Okay, the drop factor, that's also really, really common. That's the total drops per ml. Okay, the most common one will be the microdrip set, which is 60 GTT per ml. Okay, now the other one, the order. Every time you have the order on the problem, that means whatever the doctor prescribed. That's really, really important information in order to solve the problem. Availability. The availability is going to be the presentation that the drug will be used and delivered by the pharmacy. So really, really useful. And then the rate. Okay, the rate means that IV flow it's either going to be in drops per minute or in mLs per hour. So now in dimensional analysis, okay, so what's dimensional analysis? It's going to be a method that involves converting one unit of measurement to another by using conversion factors or equivalents, okay? And this is a way that you have to solve the math problems, at least for the first semester. The instructors are really, really on top of the students when they don't solve the math problems as using dimensional analysis. So it's really important to get the hang of dimensional analysis and to show your work on dimensional analysis. I've seen situations where the student solves the problem using other math ways, which there are many, but because they didn't use dimensional analysis, they will get the problem counted wrong. And this happens only in first semester. At least I see it only in first semester. Third, fourth, the instructors are not really looking for that. But for first semester, just stick to this method, and it's really, really simple. So there's specific steps in order to solve dimensional analysis. The first step will be to identify what are you solving for, okay? You need to know what are you solving for. It's either tacos, burritos, units, mg per dose, whatever. But that's the first step. Know what are you going to be solving for. And then you're going to identify the equivalents or given ratios, okay? For example, one dose will equal 10 mLs or 10 milligrams will equal one capsule, things like that. You need to identify those equivalents, okay? You need to see and analyze the problem to see if you need to use a conversion factor that is not reading in the problem. For example, let's say the order is going to be that the patient is going to take 5 milligrams per kilo per day. And then they give you the weight of the patient in pounds. They're not going to put the conversion factor in the problem. That's a conversion factor that you already know or should know by memory, but you need to know when to use it. So you need to identify that. Do I need a possible conversion factor? After that, you can set up the equation, which I will show you guys later on. You calculate the answer, and then you evaluate. The evaluation part is really important. The evaluation part can be confused with doubt. When you evaluate the problem, just evaluate, does it make sense? But what I notice is that when the students evaluate the problem and it makes sense, they start to doubt themselves. And usually they have the right answer, and they go back and do a different calculation, and this time around, they put an extra zero or they left out a zero, and they end up with a different answer. And almost all the time, when they change the answer, the first time it was right. So evaluate, but don't doubt yourself. Just make sure that the answer that you're looking at makes sense, that the unit you got at the end makes sense. So I'm going to start with the examples, okay? I'm first going to start with how to note what to identify in the order, and the equivalents. So in this case, the problem reads, the healthcare provider orders a patient to take 125 micrograms by mouth daily, and you're supplied, okay, with 250 micrograms tablets. So first of all, what is the equivalence and what are you looking for? So in the equivalence, you know that 125 micrograms is going to be one daily dose. That's going to be your dose. Now, the supplied, in this case, will be the available. You have another equivalent there, which means that you have 250 micrograms tablets. So in the bottom, you have the order. And the order, like I said, is going to be 125 micrograms daily. Okay. And then you have your available. Your available will be 250 micrograms equals to one tablet. Okay. You know that 125 micrograms will equal to one dose. So this is how you will put the equivalents. Now, can be interchangeable. What do I mean with interchangeable? Well, you can flip it. You can put 250 micrograms or one tablet, or vice versa. It all depends on what you're going to be solving for, and it all depends on what unit you're going to end up with. So this is just setting up the equivalents. Now the equivalents are going to be used as you need them. Okay, so another example. Okay, so in this case, Dr. Gonzalez orders 300 milligrams of drug X to be administered by mouth TID. TID means 3 times a day. And the pharmacy has drug X available at 100 milligrams per ml. So the question is asking, how many mLs will you administer per dose? So step one, let's identify the order. The order of doctor is going to be 300 milligrams of drug X 3 times a day. Okay, so that's the first thing. Now on step two, let's identify the equivalents and the given ratios. So we already know that 300 milligrams will give you the one dose. Okay, now let's find out the availability of the drug. Okay, that's another equivalent. So in this case, they're telling us that the drug availability would be at 100 milligrams per ml. Okay, so here we're not solving anything yet. We're just identifying every equivalence. So the equivalence here will be on the bottom. 3 doses will give you the day. 1 dose will give you 300 milligrams. And 1 ml will give you the 100 milligrams. And here I'm just setting up the dose, the equivalents to know what goes with what, but I'm not going to use them then. We're going to use them later on. So now let's make it happen. Let's see how this works and how we're going to solve the problem. So here I have a fun problem. Dr. Puss is hungry, and his hunger orders him to buy 5 tacos from the corner stand. Okay, the corner stand sells each taco with 2 tortillas. Okay, and it requires 1 kilo of maseca to produce 30 tortillas. And the question is asking how many kilos of maseca are required to feed Dr. Paz. Okay, so we go through the steps. First steps, what's the order? Okay, what are we solving for? In this case, we're solving for how many kilos of maseca are required to feed this Dr. Paz. Okay, we need to identify the equivalents. So in this case, they're telling us that to produce 1 taco, you require 2 tortillas. And to produce 30 tortillas, you require 1 kilo of maseca. So that's all the information that you need. And then we move on. Do we need a conversion factor? In this case, we don't. Everything that we need is going to be in the problem. So we don't need any other information. We can directly solve the problem with what we have. Okay? So we're going to set up the dimension analysis and calculate the actual problem. So I'm going to start writing. So we're looking for kilos of maseca. So in the kilos, like I said, when you're trying to find out your answer, you're always going to match it with the first number you're going to put on top, on the first fraction that you're going to use. So we know that 1 kilo of maseca will give you 30 tortillas. All right, and we know that 2 tortillas are required to make 1 taco. And Dr. Paz is going to eat 5 tacos. And that will be his order. So I'm going to put here in the bottom 1 order or just 1 as a placeholder. So what we're going to do, we're going to multiply across on the top and divide by the bottom. Okay, so 1 times 2 will give you 2. 2 times 5 will give you 10. So on the top we'll have 10. And then we're going to divide by the bottom. Now, dividing by the bottom, there's 2 ways that students use. Students like to multiply all the numbers across on the bottom too, and then use that, plug it in on the bottom. But I've noted that when you do or when the students do this, they tend to miss something out. And it's usually a 0. Okay. So what I recommend is to divide by each individual unit that your guys are going to be using. In this case, 10 divided by 1, again by 1, and then by 30. This will not only allow you to keep track of all the numbers that you're using, but also to keep track of the units that you are canceling out. Why? Well, because we don't want all the units that are in the problem. We don't want to know the tortillas. We don't want to know the tacos. In this case, we just want to know the kilos. So doing this way will be 10 divided by 1, divided by 1, divided by 30. So that will give you the 0.3 kilos. I'm just making the simplification of maseca. Okay, it will be 0.33333. Okay, well, this is really useful. So now I'm going to erase this and show you guys a clearer version of it so you can see how you cancel all those units. So we're looking for the kilos. We start with 1 kilo. We'll give you 30 tortillas. And then you have the 30 tortillas. We'll give you, 2 tortillas. We'll give you 1 taco. And then the 5 tacos again. We'll give you the 1 order. So the way I'm setting up this equivalence, and then the 5 tacos again, will give you the 1 order. So the way I'm setting up this equivalence is allowing me to cancel all the units that I don't want to. So what do I mean with canceling out? After you multiply across and start to divide by the bottom, you need to get rid of those units. So we don't want to know how many tacos. We can cancel all the tacos. We don't want to know how many tortillas. We can cancel all the tortillas. We only want to know the kilos. So the way I use the equivalence, I manipulate it to a specific manner to be able to cancel all the units that I have extra. I don't need those units. This is the way you're going to use the equivalence. Really, really important to understand this topic. So now we can go with the real stuff, okay? So a real mathematical problem that you will actually see in this course. A patient with HIV is ordered to take oseltamivir, that's an antiviral, 100 milligrams BID. So the patient is going to take 100 milligrams twice a day. The drug's availability is going to be at 200 milligrams in 15 mLs. How many tablespoons will you administer? So let's solve it. So what's the first thing we have to know? Okay, what are you solving for? What's the order? Okay, so the order is going to be 100 milligrams per dose, but we are solving for tablespoons per dose. We need to identify the equivalence, so we know that's going to be 200 milligrams in 5 mLs, and we know that 100 milligrams will give you 1 dose. Do we need a possible conversion factor? In this case, we do. Why? Because they're asking for tablespoons. And the problem is not telling us that there's a specific amount of milliliters in 1 tablespoon. This is information that you need to know. In this case, tablespoons will give you 1 tablespoon, 15 mLs. So now we can set up all the equation. So we're going to look for tablespoons. And we have to match what we're looking for with the top. So we know that 1 tablespoon will give you 15 mLs. And now we can start plugging in the rest of the information. So the pharmacy is going to give you the drug in a presentation that's 15 mLs is going to contain 200 milligrams. And now we can go with the order, okay? So the order is telling you that's going to be 100 milligrams per dose. So like I said earlier, anytime you see administer, that means dose. So now we can solve the problem. Multiplying across and dividing by the bottom, we can start getting rid of the units that we're not going to use. Okay, so we don't need milligrams, we don't need milliliters, but we need to. So multiplying across, that will give you 1500, and then you divide by the bottom. Like I said, I recommend dividing each individual unit. So that will give you the 1500, and you can divide that by 200 milligrams, and then you can divide that by the 15 mLs. So at the end, the answer for this problem would be 0.5 tablespoons. Let me erase that again. Oops. Okay, it's pretty straightforward, right? Is there any questions up to now on the chat? All right, I will move on then. If you have any questions, just feel free to stop me and raise your hand. So I'll move on to some extra examples. So in this case, a patient has been diagnosed with chlamydia and has been prescribed with deoxycycline every 4 hours. Chlamydia is going to be a bacterial infection. It's a sexually transmitted infection. And the order or the question is how many times, how many doses would you be administering? 1 second. Oh, sorry, there was a message in the chat. So how many times, how many doses would you be administering the drug per day? Okay, so let's see first, what is the order and what are we solving for? In this case, the order is going to be the deoxycycline every 4 hours. Okay, that means you're going to give it how many times. That's what we're going to be solving for. Do we have any ratios and equivalents? In this case, they're not giving us anything, but we know that it's every 4 hours. Regarding the time, we know that you can divide those 24 hours by 4. So that's what we're going to be solving for. Do we need a possible conversion factor? We don't. So now we can go ahead and set up the dimension analysis. In this case, we only need how many times, how many doses are we going to have? So on doses. So by the problem, they're telling us that the order has to be deoxycycline every 4 hours. So that means 1 dose. So 1 dose will be every 4 hours. And they're not telling us this information here, but we know it, that there's 24 hours in 1 day. This way, you can multiply across and divide by the bottom and cancel out all the units that you don't need. So multiplying 1 times 24, that will give you 24, and then you divide that by 4, so you can cancel all the hours, and that means that there's going to be 6 doses per day. So some of the problems are going to be really, really simple like this. Not all the problems are going to be complex calculations. Some of them will, but many of them are like this. Okay, there's just going to be extra information that you don't need, so you need to learn how to identify the actual info that you need. So I'm going to run into the final examples. I think I'm okay on the time. So this one, a child with a weight of 47 pounds has been prescribed with 5 milligrams per kilo per dose of serotonin once a day at night. This means this child is not sleeping, so he needs serotonin to sleep. The pharmacy has availability of serotonin at 3 milligrams per ml. So what's the question? How many mLs will you administer to the patient? And then here it's going to be specifically to round to the nearest tenth. So this is really important to identify what you're going to round to if you need to round. And this is usually specified by your instructor. So let's find out. So what is the order and what are we solving for? So the order is going to be 5 milligrams per kilo per dose. And we're going to solve for milliliters per dose, okay? Now, let's identify the given ratios. Which are your equivalents that you're going to use to solve this problem? So we know that 3 milligrams will give you, are going to equals to 1 ml, and 5 milligrams are going to equal to 1 kilo of that patient, okay? Now, do we need a conversion factor? In this case, we do. Why? Because the child is given to you in pounds, and the order is going to be using kilos. So they're not telling us this, but we already know that 1 kilo will give you 2.2 pounds. Okay, that's the conversion factor that you're going to need. Now we can start doing the actual dimensional analysis equation. So in this case, we're looking for mLs, per dose. And we can start with the dimensional analysis. So we know that there's, in 1 ml, there's going to be 3 milligrams. That's just based on our equivalence. We know that based on the order, it's going to be 5 milligrams per kilo. We have to use a conversion factor because we have pounds. So that means that we have to cancel out those kilos. We need to get rid of those kilos. The way to do this is that we have 1 kilo over 2.2 pounds. Now we can plug in the pounds over 2.2 pounds. Now we can plug in the pounds. They have 47 pounds. And that will give you the dose. So now we have everything set up. We can multiply across and divide by the bottom and start getting rid of our units that we don't need. So 1 times 5, that will give you the 5. And then 5 times 1 will give you still 5. Then you do the 5 times 47, using the 47 pounds. So on top, you will end up with 235. Now, divided by the bottom, every time that you're going to use the division, you're going to cancel 1 unit. I'll show you the math right now. So 235, you will divide it by the 2.2 pounds, and then you will divide that by the 3 milligrams. And that will give you 35.6. Oh, I need some space. Let me erase something so I can put the answer. And it's 0.6 because we're rounding to the nearest tenth. Milliliters per dose. And that's it. So by doing this and multiplying across, and by manipulating our equivalents, you're able to cancel out all the units that you don't need. And this is going to be the basis for the entire semester, the entire math course. It doesn't get more complicated than this. So really important to understand what you're looking for, really important to identify those equivalents, okay? See if you actually need a conversion factor, and then you know how to set up the dimensional analysis. Going back to the dimensional analysis, it's really crucial to whatever you guys are looking for. It doesn't matter if you're looking for pamphilos, whatever, milligrams, milliliters. Always start your dimensional analysis with what you're looking for. Okay, for example, here again, if you're looking for milliliters, start with milliliters on top. If you're looking for milligrams, you will start with milligrams on top over mLs. Okay, just manipulating as you need it, but always make sure these guys are going to match. Okay, the bottom is not always going to match. It's usually going to match all the way to the end. But it's really crucial to understand what you're looking for. Always start with that. If not, then you're going to bump into many problems. So with that, let's see if I can run into a different problem so that you guys can practice more, and then I'll let you guys be. I think I'm up with the time. So let's practice this one. A 70-year-old patient weighing 100 kilos has entered cardiac arrest due to an overdose of Viagra. The doctor has ordered 65 micrograms per kilo per dose of morphine. That means immediately. The pharmacy dispenses morphine at 500 micrograms per ml vials. How many mLs would you administer to this patient? Okay. So let's go again. What is the order and what are we solving for? The order indicates that's going to be 65 micrograms per kilo per dose. Okay. And we're going to find out how many mLs does he need per dose. Now on the second one, we have to identify the given equivalents. In this case, the equivalent will be the 500 micrograms per ml vials. And do we need a possible conversion factor? So in this case, there's no conversion factor needed. NFC, no conversion factor. So now we're gonna set it up, okay? And then I'll leave the rest of the time for questions. So we're looking for mLs per dose. And we know that in 1 ml vial, there's 500 micrograms. Oops. And the order says that there's going to be 65 micrograms per kilo per dose. In this case, it's a little bit different than the previous one I showed you guys. Why? Because you don't have to deal with conversion factors. You don't have those pounds. In this case, you can straight go with the kilos. So the patient weighs 100 kilos. And that will give you 1 dose. Now that the dimensional analysis is set up, now you can do the math, multiply across, and divide by the bottom. After you do that, you can cancel out all the units that you don't need, and you will end up with your final answer. So let me do the math. That will give you 13 milliliters per dose. This will allow you to cancel out all the units that you don't need and end up with the unit that you're looking for. So this is basically it under dimensional analysis. It doesn't get more complicated than this. You will run into different situations, maybe more units that you will be learning throughout your career, throughout the program, but the idea, it's the same. It will not change in second, third, or fourth semester. You will take it all the way through. So I will let you guys be with that. I'm running out of time. So thank you very much. And please feel free to contact us in the tutoring center. Here are the emails. Diana Davis is our manager at Rio Grande. Carlos Hernandez is going to be one of the tutors at Valle Verde, working for the rap department, and of course me. So thank you very much. Feel free to take any questions for the rest of the 6 minutes.
Thank you so much for the wonderful presentation, Julio. Again, if anyone has any questions here, feel free to turn on your mic or use the chat box. For now, we would like to thank everyone for being a wonderful on your mic or use the chat box. For now, we would like to thank everyone for being a wonderful audience and for coming in today. Please remember that we do record these sessions. So if you'd like to review anything or share anything from this presentation, those recorded sessions can definitely help. We have shared the Tejano Passport link so that everyone may receive their points for coming in today. And before you all leave, I want to share our TVE sessions we'll have next week. We'll be back next week with Happy Math Hour at 11 a.m., where Math 1332 will cover applications of sets and Exam 1, and Math 2412 will cover inverse trigonometric functions. Our 1 p.m. session next week will be by the Association of Women in the Community College. Thank you all for coming in today. We hope everyone has a restful and safe weekend. If you have any questions, feel free to use the chat box or your mic. Thank you again to our presenters, and we hope to see you all for the Tejano Virtual again soon. Thank you.